As a kid, I wanted to know how everything worked, and I took everything apart that I could get my hands on, except the cat. I settled on cell biology and genetics because no one knew how life worked. It was a mystery. I studied bacteria like this E. coli. It's single-celled, it's clearly alive, but it's not simple. In fact, this organism is around for billions of years. Like all cells, it has a DNA-based genome, which is a ticker tape of molecular instructions telling the cell what to be. If you change the genetic code, you actually change the organism. Now, most people know that DNA can be read or sequenced, but most people don't know that DNA can actually be written or synthesized. If you write out a gene, you can make a protein. If you write out a genome, you can make an organism. And the first person to do this was Dr. Eckhart Wimmer. He wrote out a genome for a virus. But a virus isn't really alive. In fact, Wimmer himself called it a chemical with a life cycle and even provided an empirical formula. The age of programming life really started when the first cellular genome was synthesized, assembled, and booted up in 2010. The media called this organism Cynthia. Now, Cynthia had a completely synthetic genome. And so the researchers were able to incorporate Easter eggs into the genome, a website, researcher names, an email address, and some choice quotes. Every single bacterium carries those watermarks in its DNA. Life science has become life engineering, but it's still really new. In the 15 years since Cynthia, only a handful of synthetic organisms have been booted up. And one of the reasons for this is that there's a huge technological gulf between DNA read and DNA write. Sequencing a genome is fast and cheap. Synthesizing and booting up a genome is at least 1,000 times more expensive and time-consuming. Synthetic biology labs today are capital intensive, filled with robots, and this really limits the access to these laboratories and the projects that can be done. And this is reminiscent of the early days of computing. This is a Cray 1 supercomputer from 1975. It cost $8 million, and so only about 100 units were ever sold. But just a few years later, cheap microprocessors became available, and making the personal computers affordable and accessible. And this was a game changer. They weren't powerful, they were just toys, but they seeded a new generation of programmers that went on to change the world. And today we're starting to see the appearance of biochips. These are, on the left is a DNA sequencer, on the right is a DNA synthesizer, and this is a completely new branch of chip making that could change biotechnologies. It could power desktop DNA sequencers in our homes, it could put viral detectors in our phones, and it could make printers for vaccines and medicines and even organisms. And organism printers would be game changers. You'd literally be able to download an organism and print it. You'd be able to fax organisms from location A to location B, whether it's from space to Earth or bedside to doctor, and it would make genetic engineering, cell engineering, just a new branch of software engineering. The hello world of engineering a cell, I think, is just making an E. coli glow or blink. Not a complicated experiment, one kids could do, but it's a gateway into much more sophisticated programming. A chip fab like this costs billions of dollars to set up and operate. Cell engineering is going to go so much faster. And this is why. Cells will advance at the rate that we can write new genetic software. Microbes today, but as DNA printers get better and more sophisticated, plants and animals tomorrow. Biotech is about to be fundamentally disrupted and democratized. And this is going to have huge implications for humanity and for planet Earth, because there is no other technology than programming life that is going to change the world more. It will give us the tools for sustainability, for climate change, for curing diseases, and more. Stuart Brand said famously, "We are as gods. and might as well get good at it. And as we enter the age of programming life, I don't think there's any wiser words to keep top of mind. Thank you.